is Unit 11, Lesson 6, and we're going to talk about solving sigma notation problems today. And most of the time, the sigma problems are arithmetic. Occasionally, they're not, so I need to show you both ways of how to do them. If they're arithmetic, though, they can be considered quite a bit easier. Here's what you need to know about sigma notation. This is sigma. It's a Greek letter. Anytime you see this symbol, you know that that's a sigma. And what that means in math is that they're asking you to find the sum. Okay, so a sigma will always represent a series. And remember, we just talked about doing series in the last section that we covered. So what they're going to do is they'll give you a sigma, and then at the bottom of the sigma, you'll have a variable. It could be n, j, I. They use a bunch of different variables for this, but whatever the variable is here is going to be your variable in here, okay? And here they're telling you n goes from 1 to 5. So what they're telling you is they want you to plug in the values of n for all the consecutive integers from 1 until you get to 5. And then this sigma tells me we're going to add all of those terms together. So basically what they're asking us to do here is find the sum of the first terms going from 1 to 5. Okay, now, if we do that, first thing I'm going to do is plug in 1 into this expression. So if I plug 1 in, I get 7. If I plug 2 in, 2 times 2 is 4 plus 5 is 9. If I plug 3 in, 2 times 3 is 6 plus 5 is 11. When I plug in 4, 2 times 4 is 8 plus 5 is 13. And when I plug in 5, 2 times 5 is 10 plus 5 is 15. We have plugged in the numbers 1 through 5. And then they're asking us, with the sigma, it means add all of those terms together. So it's fairly simple. We plug in the numbers from 1 to 5, all the consecutive integers from 1 to 5, plug them into the little formula, and then add them all together. So if we do that, we will end up with 55. So this is fairly easy. That's all that it means when you're dealing with a sigma problem. Now, another thing you need to understand is how many terms are they talking about when you're dealing with sigma? And this is going to come in handy when we get into the ones that are a little bit more complicated. Well, if we're going from 1 to 5, that was 5 terms, okay? But what if it had gone from 0 to 5? A lot of people mess up and they say, well, that's still 5 terms. No, that's 6 terms. Because if you think about it, if we start with 1 and end with 5, if we just do 5 minus 1 and say we had that many terms, that's wrong. So to figure out how many terms we're going to have in our sum, we have to take the top number minus the bottom number and add 1 to it. See, the top number minus the bottom number is 4. If I add 1 to it, I'll get the total number of numbers I'm adding together. That becomes important when our sigma goes from something like 10 to 50. Add the numbers from 10 to 50 when you plug them in. Well, you need to understand what your end term is, because we're not going to do it this way. If we're going from 10 to 50, we don't want to add 40-some terms together. We want to be able to do that using a formula. So I want to show you how this relates to the formulas we used in the last section. And if I show you this with a simple one like this, it's going to make the more difficult problems even easier. So we're going to do the same thing, but this time I know S sub n is equal to n over 2 times a sub 1 plus a sub n. If I want the sum of n number of terms, okay? Well, n over 2, n is how many terms? Well, we know from here we were doing 5 terms. Another thing I could do is 5 minus 1 plus 1. 5 minus 1 is 4, plus 1, 5 terms. So n for this is 5. 5 over 2. My a sub 1 is what I get when I plug the bottom number in. A sub 1 gave me 7. A sub n is what I get when I plug the top number in. Because remember, we're going from terms 1 to 5, or we're plugging in numbers 1 through 5. So this will give us the last term. When we're dealing with sigma notation, or the sum, our a sub n isn't necessarily going to be the nth term anymore. We're going to be talking about the last term. And we're talking about the last term in the sequence we're dealing with. So the last term, when we plug 5 in, was 15. I could go to Desmos, plug this in, and I will get the same answer I got when I do it by hand. Okay? So if we're dealing with sigma notation and this is arithmetic, that will work. Now, how do I know if it's arithmetic? Well, this will be of a linear form, 2n plus 5. That's like a linear equation, right? It doesn't have any exponents in it. Your variables don't have any exponents in them. It's a simple linear type form. And you can see that it's arithmetic if you just plug in a couple terms, okay? And if you're curious or if you're not sure whether it's arithmetic or not, then you need to make sure you get at least the first 3 terms and test it before you use this formula. Again, most of them will be, but I am going to give you some series that you have to do that are not arithmetic. So here are 4 simple sigma notation problems. And basically what they're asking us to do here is, for the first one, they want us to put the numbers in from j equals 1 until we go to j equals 3. So they want us to plug in 1, 2, and 3, add those together to get our sigma or our sum. Okay, so with this one, it really doesn't matter whether it's arithmetic or geometric or neither. It could be neither. If we're just going from 1 to 3, we're plugging in 3 numbers. It's just as easy to do that by hand as it would be to try to use a formula. So I know I have to plug in 1, 2, and 3, all the numbers from 1 to 3 that are integers. So if I plug in 1, 3 times 1 is 3, minus 1 is 2. Next number I'm plugging in is 2. 3 times 2 is 6, minus 1 is 5. 3 times 3 is 9, minus 1 is 8. I've plugged in the numbers from 1 to 3. I'm going to add those 3 numbers together to get my final answer of 15. Now, could I tell if this is arithmetic or not? Well, if you look here, I'm adding 3 to get to the next term. So this one would be arithmetic. It looks like a linear type function. So it would be arithmetic. I could use a formula if I wanted to. But when you only have 3 terms, do it the easiest way possible. You don't want extra work. You don't want to create extra work for yourself. In this one, we're going from 0 to 5. Here we've got I squared minus 4i. Now think about that equation. If I were to graph something that was squared minus something else with that same variable, or x squared minus 4x, wouldn't that be a parabola? It's not linear. So with this one, the easiest thing to probably do is to plug in all the integers from 0 to 5 and then add those numbers together. So if I do that, if I plug in 0, 0 minus 0 is 0. When I plug in 1, 1 minus 4 is negative 3. When I plug in 2, 4 minus 8 is negative 4. When I plug in 3, 9 minus 12 is negative 3. When I plug in 4, 16 minus 16 is 0. When I plug in 5, 25 minus 20 is 5. I would add all those terms together, so that would give me a negative 5 as my final answer. Again, not too difficult. On the SOL, they tend to give you ones that don't have very many terms, that are very easy to plug in, find the consecutive numbers, and then just add them together. Here, we're plugging in the numbers from 2 to 6. So we'll plug in 2, 3, 4, 5, and 6. 5 numbers. Now let's think about our end value there. 6 minus 2 would be 4. 4 plus 1 is 5. 5 terms. That's what we would expect to have. So if I plug in 2, 2 minus 3 is negative 1. If I plug in 3, 3 minus 3 is 0. If I plug in 4, 4 minus 3 is 1. If I plug in 5, 5 minus 3 is 2. If I plug in 6, 6 minus 3 is 3. If you think about that, is that one arithmetic? Does this one match kind of a linear form? It does. We're adding 1 to get to the next term each time. And if I add all those together, I get my final answer to be 5. That sum is 5. I've got n equals 1 to 5, so I'm plugging in the numbers from 1 to 5, and then that 7 on the outside is telling me to multiply that sum by 7. So sometimes they may give you something outside, kind of a scalar multiplication or a distributive property that you'll have to do. Thinking about this is n squared. It is not a linear, so we cannot consider this to be arithmetic. There's no way around it. We're going to need to plug the numbers in to solve it. So if I plug 1 in, 1 squared is 1. Plug 2 in, 2 squared is 4. Plug in 3, I get 9. Plug in 4, I get 16. Plug in 5, I get 25. I'm going to take that sum and I'm going to multiply it by 7. I end up with 385. So far, all of the summation problems or the sigma notation problems that we've done have been going from a term to just a few terms higher. But what if they said find it from maybe term 1 to term 50? Well, I don't know about you, but I don't want to plug in the numbers 1 through 50 and add them all together. It's too easy to make a mistake. So we need to have a way to do those where we're using a formula rather than plugging each number in to get the answer. Now, a lot of times they are going to be this simple. It's just very simple. Plug in 1, 2, and 3, add them together, you're done. Okay? But if they go further and say add all the terms from 1 to 50, that's where you're going to need to be able to do something else to make it simpler for yourself. So I'm going to do that with this example. I'm going to ask you to do the sigma notation where j equals 1 to 50. Here is our linear example, okay? And we can show that it is arithmetic if we just plug in a few numbers. So if we plug in 1, 3 times 1 is 3 minus 1 is 2. If I plug in 2, 3 times 2 is 6 minus 1 is 5. If I plug in 3, 3 times 3 is 9 minus 1 is 8. And you can see here that this is arithmetic because we're adding 3 each time. As long as you can plug in 3 numbers that are consecutive and see that we're adding the same thing each time, that will show that it is arithmetic. Okay? Now, so what we can use here is our first term, a sub 1, is 2. The next thing I need to find so that I can use my summation formula is the a sub n term. Well, my a sub n term is going to be what I get when I plug that top number in. So if I plug 50 in, 3 times 50 is 150, minus 1 is 149. So my a sub n number is 149. So the sum of all the numbers, when I plug them in from 1 to 50, I can use the formula S sub n equals n over 2 times a sub 1 plus a sub n. And look at what I've already found. I know a sub 1 is 2. So if I plug in a sub 1 is 2, I know a sub n, the number I get when I plug the last term in or the last number in, is 149. So a sub n is 149. Now I just need to find out what n is. Well, let's think about that. To find n, I'm going from 1 to 50. So from the first to the 50th term, 1 subtracted from 50 is 49, and 49 plus 1 is 50. So n here is 50 terms. So I can plug that then in my calculator or into Desmos, and I can solve it. So let's suppose we've got this sigma notation. Sigma goes from n equals 1 to 30 for 3n. And I want to solve that using Desmos. The problem here is we don't want to put 1 all the way up to 30. So we would have to put in 1, 2, 3, 4, 5, all the way up to 30 into this, add all those answers together to get the answer. We've talked about how to use the formula to do that, and that's very possible. You know, if you plug 1 in, you'll get a sub 1. If you plug 30 in, you'll get a sub n, and you could use the summation formula for that. But we can also do these in Desmos, and so I want to just make sure you've seen how to do these in Desmos. Desmos is allowed on the SOL if you have to take that, so there's really, other than understanding why it works and how you get the answers, there's really no need to do these by hand or even with the formula if Desmos will do it for you. So I'm going to quickly show you how to put these into Desmos so that you can get the answer. So I'm going to go into Desmos, and in here I'm going to open up my keyboard, and then I'm going to go over here to where it says functions, and I'm going to look in these different sections to see if I can find a sigma. Sigma is in miscellaneous, and there it is. If I click on that, you see it puts a sigma in my box. So we know that n is going from 1 to 30. And I always just jot these down on a piece of paper and then copy them down into Desmos. And we know that the function or the expression that we're going into is 3n. And so it just automatically solves it. There is no work to that. It's very, very simple. The next one, A goes from 4 to 9. Now, one thing about Desmos, it's not going to recognize variables other than n for these because it automatically will put that n in there. So anywhere you have an A for this problem, you're going to put in an n. The sigma notation from n equals 4 to 9 of 20 minus n squared. So if I go back into Desmos, I pick up that function again. It's in miscellaneous. N goes from 4 to 9. So n goes from right here 4 to 9. And then the function that they gave us was 20 minus n squared. And I'm just going to put it in here exactly as they had it. 20 minus n squared. Remember, I'm using n instead of a. And it gives me the answer, negative 151. And then one more. Here, m goes from 1 to 6, and our expression is 50 minus m. We will put n instead of m. So I grab the sigma notation. N goes from 1 to 6, and it was 50 minus n. And that answer is 279. Just be sure that whatever they have written for the function part, however they have it expressed here, if it's in parentheses or if the whole thing is to a power, whatever it is, however they express it, you need to express it the same way when you put it into the Desmos box so that Desmos understands how to read it.